Hello everyone. So let's do some example. All right. So in the last segment, we talked about deletion operation in binary search tree. We said that, we talked about that there can be three options when we delete a node from a binary search tree. So here, let's see, we are trying to delete the node 4. So let's find the node 4 here, and let me change the pen color. So here we have here node 4. So you can see that it's actually option 1 means node 4 is the leaf node. So deleting leaf node is very straightforward. What we have to do, we can just delete the node. And here 6 had this child node 4 and we are deleting this node 4. So now 6 is going to point null instead of 4. All right, so the left child of 6 will be now null. All right, so the tree after deleting node 4 is going to look like everything same, only this node will not be there. So here instead of that it will going to look like, there will be no child, actually it will just point to right child 7. All right, now let's see, we're trying to delete 14. So let's find the node 14. So here we are. So you know how to find a node, right? So we start from the root. 14 is greater than 8. So we go right. So 14 is greater than 10. We go right. And here we are. We found the node 14. All right. So looks like 14 has a child node. 14 is not a leaf node. It has child, but it has only one child. It has only one left child. Okay. So what we are going to do here when we have, when we have only one child. Okay, now this is the node we are going to delete. Now this is the parent node of the node that we are trying to delete. Okay, so this 10 is parent of 14. So now, so after we delete 14, so the node, we have to adjust the link of the parent, right? We have that adjust the link of the parent. So instead of 14, it is going to point to something else. All right. So 14 is the right child here. So the right child will be something else and it will be actually the child of 14. Okay. So what actually we are going to do, we are going to actually just make this 13. We are going to copy this value 14 like with 13. Okay, and we can delete the only child. The 14 has only one child, 13, and we can delete this. Okay, so after we delete it, it is going to look like this. So 8 has now right child 10, 10 has now right child 13. Okay, and we have deleted 14. Now let's see an example. Here we are trying to delete 3. So how to find 3? We start from root. So 3 is less than 8. So we are going to go to the left. And here where we are found root 3, we found node 3. All right. And here looks like 3 has 2 child. Okay. So 3 is having 2 children. So that's actually our option 3. All right. So first, we have to find the replacement node. Okay, so which node we can pick to replace this node 3? All right, so we have actually two options. We can choose the in order successor or the in order predecessor. All right, so let's find and how we can do that. We can write the in order traversal and find out which node is the in order successor or in order predecessor. All right, or what we can do, we can pick it like by that. We can pick the largest node in the left subtree, or we can pick the smallest node in the right subtree. For example, here the smallest node in the right subtree is the 4. Okay, and how we can find the minimum value from from a subtree. Okay, so the leftmost node, if we have a subtree, the leftmost node is the minimum value. Say for example, here this is the right subtree. All right. So if we go traversing through the leftmost node will be the smallest node in this subtree. Okay. And to find the maximum value, for example, if we're trying to find the largest value in the left subtree, we have to start going through the right. Okay. So here the in order successor of node 3 is 4. Okay. All right. So what we can do, we can pick 4. Let's pick 4. Okay. So what actually we are going to do here, let's see, here we have node 8. All right. And it has 3 10. So everything in the left, everything in the right will stay same. So here we have 1, we have 6, 4, and 7. Okay. So we're going to replace 3 with 4. So now the new value will be 4. And then what we have to do, we have to delete the node that we are replacing this 3 with. So we have to delete the node 4. So when we are going to delete that node, we have to actually make sure how we are deleting, because we have to implement either any of this option. So when we will delete the node 4, 4 is here a leaf node. All right, so that that is going to be easy. So we're going to delete the node 4, and now 6 will not have any left child. All right, so at the end of the deletion, it is going to look like that. So the 4 will be here deleted, and the value here instead of 3 will be 4. So you can actually check whether it's still binary search tree. All right. So that's why we're picking the in order successor or the in order predecessor for this node to replace with. All right. So you can also check by selecting the in order predecessor or the largest value in the left subtree. So you can see that the largest value in the left subtree is 1. So what we can do, if we replace the value 3 with 1, then it will look like 1. Okay, then we are going to delete this node 1, and here we'll have 6, 4, and 7. Okay, sorry, I'm doing it wrong. All right, so here we have 8, we'll have 1. We are replacing the value 3 with 1. Okay, and then there will not be any child. We are just deleting that. So here we will have 6, 4, and 7. And here we have the all other value in its right subtree of node 8. All right, so you can check it will still be the binary search tree. All right. So now let's try to delete 8. So we can find it with only one comparison, because 8 is the root node. All right, and 8 is the root node, and 8 has 2 children. So whether it is root node or any other node, I mean, it can actually fit with any of the option, either option 1, 2, and 3. So here we are going to delete with the option 3, because this node has 2 child. Okay, because this node has 2 children, so we are going to delete using the option 3. So for node 8, we are going to find the in order successor. All right, or we are going to find the smallest node in the right subtree. So 8 has this right subtree, and how to find the smallest node in the right subtree. Okay, so in this right subtree, actually, okay, so this is the root, right? In this right subtree, this is the root. And if we start going to the left of left, you can see that actually this is the leftmost node. Okay, so it doesn't have anything in this left. So this is the leftmost node, and this is the minimum node in this right subtree. So we're going to choose the value 10 to replace the value 8. Okay, so let's do that. So instead of 8, the root will be now 10. So everything in the left subtree will stay same. all right, but we have to adjust in the right subtree. So we replace the value 8 with 10. So now we have to actually delete 10. All right, and how we can delete 10? So we can check that we have to delete 10, and 10 is actually a node with only one child. Okay, so that's our option 2. Okay, so that's our option 2 when we delete the node 10. All right, so let's delete 10 and it has only one child. All right, one child, the whole subtree will be actually the children of this node. Okay, that's it. And everything in the right, everything in the left will stay same. All right. All right, so we'll see you in the next segment.